Okay, so this is a Regents question. Now, it is a system of equations question. It is technically not a system of linear equations question, but it is a system. So it tells me here that I've got f of x is equal to 2x plus 6. That's one function. And my second function, g of x, is equal to the absolute value of x. Okay, so I've got two functions. Now it tells us that they're graphed on the same coordinate plane. For what value of x is f of x equal to g of x? Now, anytime you see this here, that's a big red flag that we're essentially looking for a solution to a system of equations. Okay, as I'm looking for the x value that causes the system to be equal. Okay, now again, we're thinking about what does a system of equations typically look like, is I've got one line, I've got a second line, my intersection point is the solution. Okay, now we can solve systems using substitution, using elimination, but it literally tells us here that these guys are graphed on the same coordinate plane. Now, this is the Regents. We've got a graphing calculator. So what I would do first is graph this and see what I see. Okay, that's kind of a pro tip overall, is anytime you see a question and you're not sure of what to do, is you can try graphing them. Okay, so my first function is 2x plus 6. So in my calculator here, 2x plus 6. My second equation, absolute value of x. Okay, now again, there's a couple of ways to get to absolute value. I usually like to hit math, the right button, and then enter ABS is short for absolute value. Okay. Don't forget to type the X in there. And let's take a look at the graph. Okay. So this here is my system. Okay. As I can see one answer here, and I don't see a second intersection. Okay. Now the question might be is, do you think it's possible that these two intersect somewhere else? Okay. They won't, and it has to do with the slopes of these two lines. Okay. But based on what I see here, that's not really a problem anyway, because it's only asking us for one specific answer. Okay. But my first step should be is to identify that solution. Okay. So I'm going to zoom in over here and try to see if I can get a better picture. Okay. Now, if you do happen to have one of these color graphing calculators, it is fairly accurate. So it's pretty easy to read here, as I can see this is at -1, this is at -2. Okay, this one here, 1, 2, that looks like about 2 to me. Okay, so I would say that looks like that happening at about the point -2, 2. Now, if you are using an older graphing calculator, it's sometimes harder to visualize this. So what else can we do is we can look at that table. Okay, so when I do look at the table, okay, as again, I knew that was a negative x value. So let's go up. And what do I see? At an x value of -2, both of the y values are equal to each other. So that is what my solution looks like when I have a table to examine. Okay, now going back over here, where's my answer? -2, right? Now, do again, be careful. This 2 here, that's actually what the y coordinate was. Okay. They weren't looking for the y coordinate in that case. We wanted the value of x, which is pretty much what you're always looking for in a question like this here, is we want to figure out what x value forces the two functions to be equal to each other. Okay, but that's pretty much it. Again, remember, when in doubt, graph it out.